Hello and welcome to presentation 6.1, and this is a treatment of the normal distribution, and we're going to look at a summary of the empirical rule. As you can see here, for population mean of 72, sigma equal to 8, the percentage of data within one standard deviation, z equal -1, z equal +1, or between 64 and 80 is 68%. We extend that to two standard deviations, -2 to +2, 56 to 88, that probability is 95%. Now those values come from what's called the empirical normal probability table, and if you look on the screen here, the z-scores are going down the left column, and the refinements of the z-scores go on the right. And we're looking at 1.00, and you can see that suggests that there's a certain probability 8413, and that represents the area, cumulative area from the left up to z equal to 1. That's 8413. The area to the right of that is 1 minus that, or 15.87. Now we're going to apply that. For a population mean of 72, sigma equal to 8, the probability of getting an x value between 64 and 84, we plot them on the x-axis, look at the boundary lines. On the left, the z-score for 64 is -1. For 84 is 1.5. Going to the table, 1.5 probability is 9332, and that is the area up to that red line. And then going to -1, that area or probability is 0.1587, and that's the area that you see here. We're looking for the area in between, and as you can see at the top, this is the difference of those two, which turns out to be 77.45%. If the bottom 6% were to receive a failing grade, what would the cutoff be? We're now looking at a case where the area in the left tail is 0.06 and trying to find a z-score. In this case, we go to the table, but we must go into the body of the table, and you search around there and you find it's down here. 0.06 is between these two values, and this z-score here at 0.0606 is -1.55. On the right is -1.56. And we're suggesting is halfway between those two values. We add a 0 to each, and halfway between these values is -1.55. And here it is up here. Here's our z-score. Coming down, we convert to the x value, which is very straightforward. The cutoff for x is 59.6. Rounding up the passing grade, it would be 60%. And if the top 7% were to receive an A grade, we again look at this area in the right tail, 7%. We must convert to the left because of the cumulative probability table, and that is 93%. And we go to the table, and 93 is over here. As you can see, it's almost halfway between these two values. Z equal 1.47 and Z equal 1.48. We're going to do a little interpolation here. 0.9292 and 9330, in between is 93. That's 1.47, and on the right is 1.480. And we're now saying the distance across here is 14. The distance across here is 8. And we're going up the top here. The distance across here is 10. And here is x. And we're going to do a little ratio here. X is to 10, is 8 is to 14. X is 5. So we just add it to that left boundary, or probably plus 1.475. That's your z-score. Going down, we compute the x value, and the x value turns out to be 81.8, which we would round off to 82, would be the passing grade for an A. And that's the end of presentation 6.1. We ask you to review this as well as you can.